25,000 volts AC, powering the railway's mission to become greener, quieter, quicker. Extending the reach of electrification will bring many benefits, but getting there involves overcoming hundreds of structural challenges, such as the scale and scope of the ongoing programme. Sadly, Victorian engineers didn't foresee a future need to retrofit their infrastructure with overhead line equipment. Where there's a will, there's a way though. Down the Thames Valley, through the Midlands and across the north, wires are going up. Scotland is getting more too. Known as EGIP, the Edinburgh Glasgow Improvement Programme will see the introduction of new 8-car electric trains on the main line between the two cities. Some of the OLE has already been installed. This is Linlithgow. Out in the open, the process is relatively straightforward. Not so though when it comes to structures. As part of the wider programme, 61 of them have had to be rebuilt to accommodate the new equipment. And continuing to focus the minds of engineers is one landmark project over in Glasgow. For 20 weeks, it's all change. The high-level approach to Queen Street station is closed, resulting in trains being diverted to the low-level platforms and Central Station a few hundred yards away. Being pushed forward is a considerable package of work, with platforms extended to handle the new trains, track layout changes in the station throat, and through the 1,000-yard approach tunnel, renewal of its degraded 40-year-old slab track. The logistics involved in servicing all those activities have demanded critical attention.
Well, as part of the intensive planning before the project, we decided to keep one line open at one time. So we initially kept the down line open fully, and we excavated out on the up line. So that allowed us to get engineering trains into the station to deliver plant materials and take away spoil from the station and from the tunnel itself. So by keeping one line open at all times allowed us to have 2 engineering trains in per day, one during a day shift and one during a night shift.
As slab track provides a higher level of fixity than ballast, standard clearances between trains and structures can be reduced slightly. That said, even after breaking out around 10,000 tonnes of concrete to a depth of 600 millimetres, around 250 millimetres of sandstone and mudrocks still had to be excavated to create sufficient headroom for the conductor bar that will carry the traction current. The new slab track, an Austrian system, has a design life of 60 years. Installing it required concrete to be pumped down the tunnel's 2 capped construction shafts.
We put in a base slab for it, and that allowed the rhombic pour panels to come in. They're 5 metres long. They come back in on that section. They're laid against each other. They got levelling jacks coming through, and that allows then the rails to put in, lined and levelled. We basically then shut it up through the system, and the lifting holes allowed in the panels allowed the grouts to come in and set the whole unit homogeneously together.
Whilst the tunnel does tend to grab the attention, of no less importance has been the work taking place around the station. With the pre-existing tracks removed, new drainage and multiduct was installed before work got underway on a new layout to align with the extended platforms, incorporating 7 S&C units in the throat and 4 more in the tunnel. The signalling infrastructure is also being renewed, with axle counters replacing track circuits. All in all, it's expected that an average daily workforce of 70 will have worked a total of 500,000 man-hours by the time Queen Street High Level welcomes commuters again on the 8th of August. A 2-year redevelopment of the station buildings is on course to begin in November.